Good afternoon. I'm speaking from my office. Please excuse the disarray. It stays this way most of the time, but I've been rearranging some stuff, and so I've got a little bit of a mess drug out. But that's okay. We're going to talk about Module 2. This is in preparation for your online session, and I expect that you've already read Module 2 and that you will, in your mind, kind of go back over the things we said in class about Module 2. I'm going to very briefly recap those things, and then I'm going to jump into a little more detail on the parts that we have not yet discussed. But first, I want to remind you we're talking about project management in general, and more specifically about systems development. Now, what do the two have in common? Because systems are developed as projects. We've already covered this ground in class, and we understand that teams get organized and they work together to develop software systems among other projects that occur across all organizations and industries. But we're concentrating today on a software or a computer-based solution as we as CIS people develop solutions to business problems using the computer technology. So we've talked about the fact that there will be some formal mechanism for requesting upgrades or new systems, new applications, whatever, and that that will be a management type activity, and ultimately a few of those will rise to the top as being the ones that we're going to fund this cycle. And of course, they're going to rise to the top because they're going to be the ones that are going to make the greatest contribution toward meeting the goals of the organization, or perhaps providing some strategic advantage to the organization. We've already talked about how they might be pursuing opportunities, new technologies that are going to allow us to pursue some opportunities, or for whatever reason, an opportunity, we see an opportunity, and we believe that the development of such a system would allow us to take advantage of that opportunity. Sometimes we're addressing problems, sometimes we're addressing opportunities, and sometimes we're addressing directives, things that some agency or someone in power has said you will do this. But at any rate, there's a process to go through, and we're going to assume at this point that we have been handed a project, a request that has gone through this first layer of approval, and at this point in time, management thinks this is probably a reasonable problem to solve or an opportunity to perhaps try to capitalize on. So they're handing it to us and saying, here you go, start your project. We talked when we last met about buy versus build, and we know that we can either go buy it off the counter, and we talked about how that would be quicker, less risky, already tested, but rather generic, so it may not match us real well, and it's certainly not going to give us any unique capabilities if it's a generic program that all of our competitors could also purchase. But if we don't have, the time, the money, or the need to create some advantage from it, it may be the perfect solution. But we're going to concentrate on the rest of this module on the idea of building. Now, when we build, we can either build with our own staff if we have a development shop or if we have the resources to acquire that, or we can outsource that build. We can actually use outside consultants and building teams. And of course, the more outside or external this process is, the more trouble you could have with integration and matching cultures and things like that. Obviously, it does bring another layer, but it also brings talent, skills that we very possibly don't have in our organization, or maybe don't have the money or the resources for. So make sure you've looked in your book at the buy versus build and the advantages and disadvantages. If you build it, it's custom made. It's going to fit you like a glove. You have the opportunity to make it be just everything that you need. But it's very, very lengthy, depending on how big the project is. But it takes a long time to develop your own. It takes a lot of skill, a lot of resources, meaning a lot of time, a lot of money, a lot of people. So it's not going to be quick, and you've still got to do all of the testing. And you don't get to maybe do a test run because it's not been created, and until you get it created, you can't even begin to try it out. So all kinds of things we could say about the risk and the resources, but still there are times and reasons why. Think back to when we first started using computer-based systems. They were very widely, virtually all of them were created and built because there was no software industry back in the 50s and the 60s. And even down through the years, as the software industry has developed, it's not been as fleshed out as it is now. We understand that today you can buy general purpose software out there for just about anything. It's pretty amazing. So it really gives the organization a real choice here in terms of, do we build or do we buy? Now, having discussed all of that, let's move right into what I want to talk about. And I'm going to kind of rearrange the screen for you here today, and I'm going to put up our outline that has been posted for you on Blackboard. And basically, once we start, we talked about that there are different methodologies for development. And I explained to you that we're going to talk about the waterfall method. We're going to talk about this one because this is a very widely used methodology when you're using outside consultants because it really has a lot of management control involved. It's very sequential, it's lengthy, it's well thought, it's thorough, but it's also kind of rigid because like a waterfall, if you can think of a series of waterfalls and you can see, water cascading down and then keep going and keep going. That's what happens, and that's why it's called waterfall. When you do the first phase, the output of that falls down and becomes the input for the second phase, and then likewise that flows down and becomes input to the third phase, and so on. The reason I call it rigid is because the waterfall is constantly falling downward. There is no iteration, there is no back and forth. When we leave one phase, we get approval and we move on, and we never really, the methodology does not allow for going backwards, if you will. So I want to talk to you about these phases, and I've already said in class, we're not going to say as much about the technical phases. What we're trying to help you understand is what a systems development project kind of looks like. This is for business students, and it's also for our CIS people, but they'll get plenty of exposure to the coding and the back phases and the design and all of that later. But all of you are business students, and so we want everybody here to understand from a business perspective. One of the first things I've said to you this semester, and I'm going to keep saying it, is that as CIS professionals and information systems people, we enable the organization to meet their strategies and goals and so forth. We're not we're not the drivers. We don't implement software just because we can. We implement software to solve business problems. So understand the business case, how important the business case is, how important it is that the analyst understand the business in general, and your business in particular, and your specific problem in particular. This is a very, very, very important skill. You have to know the business very, very well to be able to conduct these early parts of the project. Now, once we get to the design and more into the actual construction phase, you can hand, your information off to a coder and say, now write this program for me. I'm sorry, I had an email to come in and kind of get over the screen. But anyway, I just kind of want you to see the whole process here. So we're going to start, and I'm going to tell you that if you go to any organization or you look at 10 different textbooks, you're going to find 10 different steps and names and all of that. A lot of people call this first phase planning. A lot of people only have 4 phases. They'll say planning, analysis, design, and execution, or maintenance. They won't even maybe put that in there. But they're not saying different things. They're just not drawing it out into much detail. Your textbook gives you 6 phases, but again, it's the same activities. So let's start with the first one, systems investigation. The bottom line, what I've put on this outline for you is a reminder that the whole purpose of this phase is to understand clearly the specific problem or the specific opportunity. And that means, what is the scope? How big is the problem? Is this an organizational wide problem, or is this just in one department? Who's impacted and how many are them? How are they impacted? How often has this problem cropped up? Or how often would we need to use this system to address or improve this situation? And ultimately, is it worth addressing in a big sense? Because a lot of things, we could improve them, but it's not worth spending the money. The faucet's dripping, but it's only costing 10 cents a year, and I don't want to spend $1,000 to fix that 10 cents a year, to use kind of a silly example. But I want you to understand the systems investigation, which is often called planning, is just kind of planning the project. So you're sitting here saying, okay, what is our problem here? You're going to review that request that has come down, from management. You're going to look at the formal request. You may refine it. You may say part of this is not feasible or not reasonable, or but basically, you're going to be looking at this, how well it aligns with strategies and the general scope and so forth. And at some point, you're going to identify and recruit your team leaders and members. Now, these team leaders and members may change. You'll notice in your book that it may talk in other phases about organizing your team. Right now, we need a lot of business experts and a lot of organizational people that understand clearly what's going on in the organization. We need technical consultants, that will maybe flesh out any technical misunderstandings or lacks of understanding that we may have. But we really need a lot of people from multiple levels and just people that really understand the organization, business in general, the organization, and the problem. And then, of course, you've got, you're going to do whatever needs to be done to organizational kinds of things. One of the first things you're going to do is develop a budget and a schedule for your investigation. You're going to say, okay, you're going to start organizing the actual investigation. This should take us 3 weeks, 6 weeks. It depends on how big the project is, obviously. But you're going to decide what are our objectives for this phase, and you're going to come up with some milestones. And milestones are critical for management. If we just say, I'm going to try to get this finished by next May, that's a long way out. And January, I'm still thinking that's a long way out, and I've got a long way to go. But if I have actual milestones that remind me that I've got 4 major milestones and it's January and I've only met one of these, hey, I may be in trouble. So milestones are just points of completion that help us stay on track. But ultimately, we set up that budget, and this is going to be kind of what you're going to use a project management software for your assignment that you're going to be completing for Module 2. where you're going to talk about tasks and activities and how long they take, and set up a timeline, and the salaries and the other costs that are involved, and you're going to deal with these kinds of things. Now, so we review the system request, we organize our team, and we start to do an initial investigation. And this is going to be, the next phase is going to be analysis. And many of these, in general, it's going to be kind of the same goal with just much more specificity. But right now we're doing a real kind of a high level definition of the problem and the scope, and what in general, what are the business requirements. We need to be able to to provide a website and have a fully operational website where people can conduct transactions, and we need to be able to have a chat function and we need to, it needs to tie to whatever back end. So this is what we mean by high level, what kinds of requirements, what are the outputs or the actions that this system has to take. And then we have to begin to look at major issues and risks. We've never done this before, or this is similar to something we've done, or this is going to be a complete change in the way we've done things in the organization. So we begin to identify what we see as potential problems and risks. Your book talks about JAD, a Joint Application Development sessions, and these are structured meetings that are very, very participative, and you get people from all levels and a lot of diversity. And this is be sure and read in your book, but this is just one type of way that sometimes the team has these sessions sometimes with facilitators. The facilitators are really key here. So again, this is not like, okay, we have to do a JAD. This is just one of the tools that we often use when we're in these in these phases. Functional decomposition is also mentioned. This is just simply coming up with a little chart that, again, that's talking about the basic functions that, you've got to capture sales, you've got to record returns, whatever. And so functional decomposition just simply means breaking things down into smaller parts that will be much easier to handle. It's kind of like peeling an onion. You just keep taking it off one layer at a time, and before long the onion's gone. If you try to just take that onion and pull it apart, that's very, very hard to do, if not impossible. But if we pull it apart layer at a time, each layer is manageable. So the idea of decomposition. And then in this phase, as a part of trying to get our mind around what the system needs to do, and we're doing a really high level analysis, because at the end of this phase, management's going to say, well, you've taken this request and you've looked at it more carefully, and you've suggested to us that we keep going, and we think you're right, and so we're going to let you keep going. At the end of every phase, management may very well say, stop, we don't need to do this any longer. So what I want to talk to you about briefly here is what we mean by feasibility analysis. We all kind of have heard people say, is that feasible? Meaning, will that work? Should we do it? Does that make sense? But oftentimes when we think about feasibility, we think we're just talking about money. Does the benefit outweigh the cost? And that is one of the feasibilities we're looking at. And your book gives you a cost-benefit table to look at. That is one of the things we're looking at. But that's only one way. Oftentimes things are financially feasible. Your parents have often probably said to you, or you've at least heard adults say to a child, we can't afford that popsicle, or we can't afford that new bicycle here in the middle of the... Probably that's not an accurate statement. They probably literally might have the money, but what they're suggesting is that it's just kind of not feasible that we spend that money. So economically, what are going to be the benefits of doing this, and What are going to be the costs? What kind of revenue increases are we going to see? What kind of cost reductions are going to result? And then versus what it's going to cost, not just what it's going to cost us to build or construct this system, but over its lifetime. What's it going to cost every year? Are there more costs? What are the maintenance? So we're looking at that big picture, and we're deciding whether this is something that we should continue with. Technical feasibility, we look at our available technology. Will the technology work? Do we have it? Can we acquire it? Are we going to totally have to rewire the whole house? Are we going to have to bring in some, spend some money on some technical issues? And can we even make it happen? Legal, are there laws or regulations that might prevent or limit the project? Not just today, but are there any that we think may be coming down the pipe in our organizations? This is a very big concern when we're dealing with global organizations. Often something as simple, for example, data. Every country has different laws and practices in terms of what data they allow to cross into and across their borders. So some of these issues are simply, are we going to let people in the other countries see our database? So all kinds of legal concerns, and there could be legal concerns because you've got some kind of a legal contract with another vendor that limits what you can do otherwise. Operational, this is a biggie. Will it really work? Well, duh. I remember though that when I did some remodeling on my house many, many years ago, one of our big concerns was, will it work? Well, of course it will work. We're going to have a door that opens into the outside. The garage door is going to open. The bathrooms are going to flush. I mean, what do you mean by will it work? But what we were concerned about is that, yeah, we're going to put all this money into it, and we're going to have a house that works. We're going to have a nice home. We're going to have a home that a lot of people would love. But is it going to meet our needs? Is it going to work in our environment, in our culture? Will our people accept it? Will it meet the expectations of our people? Will it be used? I've already talked to you in class about how user satisfaction is so important. Finally, we're going to look at schedule feasibility. Can this happen in the time frame that it needs to happen? If there's some deadline and we don't think we can meet it, well, then maybe we need to back up and punt. I'm going to talk to you at the very end of this about your Module 2 assignment, and I'm going to say something to you about the triple constraints, and I'm going to talk to you about how time, scope, and money, and we can look at it like a triangle with time up here and then maybe scope over here and money over here and quality in the middle, and I'll talk about that in a minute. But the bottom line is all three of these have to be constantly balanced. And if we've got to crunch the budget and bring it in the schedule and bring it in less time, that's probably going to mean we're going to have to trim the scope a little bit, and or we're going to have to throw a lot more money at it. So that's the big deal in projects, is totally balancing at all times this whole project and are these three constraints. So here, we look at the schedule feasibility, and that kind of plays off of the economic feasibility, and it plays off of the scope. But then if we cut down the scope to meet the time, will it still be operationally feasible? Will it still work? Will it still satisfy? So it really gets to be a balancing act. The bottom line is, in this first phase that many times is called planning, it's called investigation here, what is the problem? Let me understand it better, or the opportunity. Let me get my head really wrapped around it. Let me flesh it out a little more. Let me list and get a little more detailed on benefits and cost. And let me ultimately look and see, as we've organized as a team, okay, now let's see, is this economically, technically, legally, operationally, and schedule-wise, is this feasible? Bear in mind that we have no a real idea what the solution's going to be yet. So I cannot tell you. When I remodeled my house, we sat down with the contractor and we said, if we add on this and take away this and move this and do this, he said, well, I would say you're talking somewhere in the ballpark of this. Because if I say I'm adding 2 bathrooms and he says, well, this is what a bathroom usually costs, but the second one will be a little cheaper because it backs against the other one. So I would say both bathrooms can come in for this. So, and I would say moving the HVAC, and I would say, and so we got those big picture numbers. But, he wasn't counting 2x4s and nails at that point. It was not detailed. And you can assume and understand that it's going to change. But you got to start out at that high level. At the end of the day, the output of this is a report that you're going to share with the steering committee or with management. You're going to sit down with this investigation report and you're going to say, after we've looked real closely or pretty closely at this problem or this opportunity, this is what we think. And you're ultimately going to recommend, we think we should probably do it. We think we could do this and save this much money and spend only this much money. We think it'll take this much. Here's our ballpark, our time, our money, and, all of our estimates. And then, of course, there will be decision time. This is why your book tells you that it's very has a lot of management control, because managers get to be involved. Notice there was not a lot of user involvement here. That's going to be one of the big drawbacks of the waterfall methodology, because the user doesn't interact with this system until it's finished and they actually go into testing and so forth. So even though they're going to be consulted, but they're not going to interact with the system at all. They're not interacting with it as you're developing it. It's all the development team until the end. So that's one of the drawbacks of this. The second major phase that we're going to talk about is the systems analysis phase. And most people do call this the analysis phase, but I want to slide down here and remind you that your text says this is the most important step in the waterfall process, because the bottom line, this is the step where we kind of determine the requirements and we say this is what this system needs to do. The analysis phase is all about what the system needs to do. When we get in the next phase, we'll get more physical and we'll worry about how we accomplish the what. Right now, we're only worrying about what the system needs to do. But the textbook reminds us that if we get a wrong picture of what it needs to do, we're going to go ahead and reinvent this or invent this wheel, reinvent this wheel, and we get to the end, we're going to have a wheel and somebody's going to say, but we didn't need a wheel. We needed a whole wagon, whatever. So we've kind of wasted our time because we did the wrong thing. So all of these are important, and it's hard to say which is the most important, because obviously if you don't do the coding well. But the bottom line is, if you get off track here, you've just derailed the whole project, whether you realize it or not. And it is during this step that a lot of agile or rapid development comes in. We say the purpose of this phase is to ultimately, the output is a list of requirements and then a recommendation. This is what we think the system would need to do, and we recommend whatever. Well, what if you're dealing with a system? You see, remember when we first started Waterfall, systems were very, like a transaction processing systems. Payroll is payroll. You may do yours a little differently, but it's easy to understand. We know what payroll does. We know what capturing sales does. It's not mysterious. So right up front, I can begin to develop those requirements. In other words, I can develop the recipe and then go bake the cake. What if I can't develop the recipe up front? What if you're asking the users and the users have no idea? I've mentioned my website when the young man came in and was asking me what I wanted my website to look like and to accomplish. I had no idea because it was all new and different to me. I'd never had a website. They were all brand new. So sometimes in this environment where things are very fast moving and changing, we may not always understand exactly what we want. So plus, we may know what I want today, but something may change because everything's so dynamic today that sometimes things change within the 2 years. And yes, you may be 2 years developing this system. But anyway, things may change. So because of dynamics and because of the nature of what we do today, it's not always possible to know up front, and or it's not always possible that the recipe we created today will still work, a year from today. So in those situations, we oftentimes use what we call an agile approach or a more iterative approach. And this is where, like with my website, Romero threw some things down on paper, sent it to me, and I looked at it, and I said, yeah, no, whatever. And then he creates, the first page there, and I call it up on the screen, and I'm like, I don't like that. Can you move this? Oh, wow, it would be good, And so it's going back and forth from Romero to me, and we're in that iterative fashion. And we're also moving much faster. It's kind of like you're going through the whole process, a spiral, all 8 phases, all 8 phases, all 8 phases. You're going through at a much faster pace. So I just want to mention that's what I'm talking about here when I said this is where some of the rapid development comes in, because you can't always know it up front. It may need to evolve, if you will. But now let's back up and say, okay, we get it. The first phase was about getting our team organized, understanding about, kind of getting us a preliminary budget and schedule going, getting our head wrapped around the problem, what we thought it was, doing some initial feasibility so we can say, you know what, in our report, we think this should be, you should go on to the analysis phase. Once you hit the analysis phase, this is very, very lengthy, again, depending upon the project. But you're going to have to understand fully what this system must do. You're going to be looking at the current system, although we don't spend near as much time there. But you're going to look at the current inputs and outputs. You're going to look at business documents, forms that people fill out, reports that result from the current system, procedures, policies, manuals, documentations. And then you're going to do things like direct observation, surveying the users, and interviewing certain users, because you're going to be trying to find out absolutely everything you can about what the system needs to do. And so you're going to, again, maybe add people to your team, maybe not, maybe you've had time turnover, or maybe you need more skills. You're going to, again, develop your budget and schedule for this part of the process. And I've written here that this is what your hands-on project that you're going to be doing is kind of like, as I've already mentioned. You're going to be, of course, thinking about the resources you're going to need, and you're going to study that existing system, and then you're going to, very, very detailed way, you're going to study the other systems. Ultimately, you're going to develop requirements. And you're going to end up saying this needs to be our output, and therefore we need this input if we're going to get this output. And you're going to come up with kind of a prioritized list. It's like if you go car shopping. Well, it's got to be fully, electric and have, power locks, which they all have now, I guess. But, it's got to have maybe a certain level of a stereo system. Has it got to have a backup camera? Absolutely. Or that would be nice to have, but I can live without it. A sunroof would be nice to have, but I can live without it. So what we do is we develop this list that says these things are absolutely critical. I mean, the system's just not going to work. It's not going to, this car will not meet my needs if it does not have all of this. That's baseline. But then you might have the next level that's like, now, it would be nice if we have the time and money, if it could do this. And then you have some things that, you know, the Cadillac, if you will, yeah, stuff that, you know, but the bottom line is we usually look at different levels of functionality, and then we attempt to determine, you know, we kind of categorize them. In some way, we come up with alternatives, and maybe this alternative comes up with not the full system. It stops at this functionality and says maybe next year we'll add on another module, whatever. But this is what we mean by the alternatives. And during this phase, you're going to develop, well, we could do A, B, or C. And then you're going to have to back up and do these feasibility analyses and these cost-benefit analyses on A, B, and C. So when you go to management at the end of this one, you're going to say, well, we've done a much more thorough, and we now have a full set of requirements, and here are three. Three is just a number that's often used, but here's a couple of potential alternatives, and we recommend that you do continue and that you go with alternative 3, and here's why, and so forth. And then they can look back into your documentation and come up with, you know, and study more about that if they will. It is during this time that we might use DFDs and ERDs. And I'm going to pull one of those over here onto the screen for you. And let me back up to this DFD, and please excuse the watermark. This is just from a preliminary version of the book that I got to look at, and so I'll just stick it up here for you. These are, I just want you to understand, once we collect all this data, it's still just data laying there. We've got to make sense of it. We got to make the data tell us, okay, I've talked to everybody, and so what we do is we use tools such as this one. This is a data flow diagram, shows data flowing through the organization. It's also called a process diagram because it shows the various processes. What we've done is, after talking to people, I've figured out that basically what are the entities that are involved in this system? Well, we have a customer, we have a warehouse, and we have the accounting people. And this, by the way, is just one. Well, let's just say, and what I do up front is I usually put them around the edge of my document, and this kind of lets you see my scope: customer, warehouse, and accounting. And then I identify the major processes. Well, we need to be able to check the status, we need to be able to issue a status message, we need to be able to generate a shipping order, we need to be able to manage accounts receivable, and we need to be able to produce reports. So these are the processes. And notice these numbers. I can blow this process up in a subsequent diagram into a bunch of sub-processes. But here we go. We show that, because what we're trying to depict here is what data is coming into the system, where it's coming from, because we've got to make that happen. So we're saying, okay, the customer sends an order into the check status process. And out of that process comes order data that goes into a little storage area, a database, a file called pending orders. And of course that is pending, and then it ultimately becomes order data that goes into the reports. But again, notice that here you're saying a status data goes into this, and a message is issued back to the customer. So I'm just showing you what these items on here are, so they make sense to you. When the order goes in, we check this. If you need to check the status of the order, this is that process. The data goes here and the message comes back to you. And then the in-stock request, when you place the order, immediately they're checking with the warehouse to see if it's in stock. And then you see here that this data comes all the way back down here because shipping information has to go to accounts receivable. So again, without going through a huge amount of detail, I just wanted to point out the parts and pieces on this. The next thing I want to show you is the entity relation diagram. This is what we use to help us understand how to structure the database. And what we do here is we talk, what are the entities that I'm keeping data about? Now, there will be a relationship between items on this and items on this. We won't worry about that. But this is just another one of the tools where we say, you know, we need to keep data about our salespersons, our customers, our orders, our invoices, our specific products, and we're not going to talk about line items. That's a little more complicated at the moment. But basically, you begin to draw it and say, okay, a salesperson serves a customer, and a customer places an order, and an order generates an invoice, and an order includes products. And if we just say products, well, that's not very specific. That's what line item means. An order includes line items that specify a product. Now, these little crow's feet here, this is suggesting there is no crow's foot up here. So this is suggesting that one salesperson serves many customers. Maybe one customer, maybe many customers. But a particular customer is served by one salesperson. So why do I need to know that? Because this is how our business rules get made and how our database integrity is maintained. So again, this is just a quick glimpse at a couple of the tools that get used to help us understand, you know, our data as we're pulling it together. Just wanted to show you those because your book talks about them. Now, at the end of the day, we've evaluated these alternatives and we've performed the additional, and we review the results and we have a decision. Now, from here on, we don't have much more to say except to share with you that from this point on, it starts getting pretty technical, and only if you're a technology person would you need, all business people do not need to concern themselves with this, but you just need to know, you know, what the rest of the process is. We have done the what is the problem and what is the solution. Now we began to worry about how. We began to worry about the technical details, the interface, the specific. How are we going to get this data in? How are we going to get it out? What kind of controls, security, and so forth. We began to specify that we'll use this hardware and this software and these network components, and we develop our procedures and so forth. We end up with a set of technical specs. And we then, of course, again, at the end of this process, we meet with management. Here's the how, here's the technical specs. Again, we could be told, abandon now. I know we've spent a lot of money, but it's now obvious it's not feasible. That could be the case, but assuming it's not, we go on into construction. That's where we actually write the code. And we actually put the data in the database, transfer data from other places, and we perform our testing. Now, I do want to call your attention to some of the testing, and I want to tell you this may show up on your exams, but it's not going to be anything. It talks about integration testing. Well, integration testing is just what it says. It's testing how the modules integrate, how they work together. Does this module really work with this module? We're looking at system testing. This is a test of not any particular, it's a test of the whole system, if you will. It's a complete you're trying to make the system fail at this point just to see if you can. Volume testing looks to see if it's going to work at all volumes. What if we have a heavier load? At what point does it become brittle? Does it work at this level, with this many products, with this many customers, and so forth? And user acceptance testing is really, really, this is where the user actually gets involved. And you have trained users that are using it, and they're going to start letting you know what doesn't fly, or what they like or they do not like. This is very, very critical. Once we've done all the testing, and of course this takes a huge amount of time, we're ready to actually implement. And you've got to prepare the users, you've got to prepare the site, and then you're ultimately going to do the installation or the cutover. One of the things we have to understand about the cutover, that there are multiple ways to do it. We can just turn off the other system and turn on the new. That's called direct cutover. That's the very cheapest method, because we never share resources, so we're not going to have two systems running at any time. So if you need to use the hardware out of another system, or you don't need extra space and so forth, so you never run two systems at the same time, so you don't have that cost of that redundancy. But it's also the most risky, not something you'd want to do in surgery. If we have to have multiple backups for power in case power goes off while somebody's in surgery, because it could be, deadly. And so it's very, very risky to do this. But if you're not in an extremely risky situation, then you do this to save money. You can also phase in, where you bring in a part of the system and then you bring in another part of the system, or you can bring in what we call the pilot, which is you bring in the whole system, but you only give it to some of the people. So you either phase in by department, the whole system with part of the people, or you phase in all of the people but with just part of the system. So you can do phase or pilot. Ultimately, it goes then into operation, and you monitor, and you back away. Your job's over. It is now operations, and then we have, of course, maintenance. As we go through maintenance, your book talks about a few terms like slipstream, upgrades. These are minor upgrades, but they still can create big problems. A patch is a minor problem correction. A release is a more significant change that may need more documentation, and a version is really a drastic. It's a major. It has new features and so forth. And I think one thing I did not mention back up in the construction phase was the documentation, which is so critical and needs to be ongoing, but certainly has to be finalized and during this construction phase. But your technical documentation is for the technical people that are going to build and maintain and really need to know how the system is working. The user documentation is written in very friendly language that is telling the user, how to interact with the system. Now, as I want to just mention to you real quickly, and if you'll just real quickly, and if you'll bear with me, I'm going to find I forgot to bring down your other assignment, but I want to talk to you about your assignment for just a moment, please. And if you're, I don't have the assignment handy, I'm sorry. But anyway, what I did share with you was I shared with you the triangle that mentions, as I said a few minutes ago, that mentions the triple constraints. And if you look at that assignment document, you will see those triple constraints, and you will see that I talked about how scope, time, and cost all have to be balanced. And if you're going to add on a couple of little applications that's increasing the scope. What happens is we often let the scope creep, and we don't go ahead then and change the budget or the calendar, and then we're surprised when we come in over time and over budget. We need to understand if any one of these move, we need to go and deliberately look at the others and see how that adjustment needs to be made to keep it all balanced. And sometimes if we find ourselves in a money crunch, we may have to back off of the scope. We may have to back off the scope so we can back off the time because we're running out of money. So it's a big management challenge. And suffice it to say, there is a great deal out there of just a great deal of failure in the area of project management. And if you, I've already said all of this a little bit in class, I think, and I talked to you about this on that document, but I just want to mention it a little bit so that it will make a little more sense to you. But the bottom line is the project managers, you have to be constantly aware of, monitoring and controlling for, your schedule, your budget, and of course your scope. How are we progressing? You oftentimes see people that are trying to reach a goal and they'll have a big display that'll show they're 5% there, they're 20% there. We've talked about milestones. How do I know if I'm on schedule? And oftentimes you've found yourself in this situation where you thought you were on schedule and then everything just pops you at once and you're like, oh my Lord, I thought I had things under control, but I see now I've got more to do today than I can get done. And so we all kind of understand how that gets out from under you. Also, the scope is so wide that you can't see it all at once. Your span of control is not as manageable. So one of the things we do today is we use a project scheduling software, and you are going to be introduced to that with Mr. Powers. And you're going to have this particular document, your Module 2 lab document, gives you some specific tasks. And I've talked to you about those tasks, and I've said some of them have to be finished before another one starts. Some of them can be done at the same time, whatever. I've given you some resources. You can assume these people can work on this, and this is how much they get paid an hour. It's very, very simple, okay? But it gives you a framework to put into this software so you can then set back and you can say, now, if I need to reduce my resources, how might I do that? Oops, this is telling me I don't have enough analysts to really, even though I've said this only takes 5 days, well, I don't have enough analysts to make this happen in 5 days. So I'm really going to have to stretch this out, or I'm really going to have to change this. So this is a way to constantly monitor and constantly control and manage all of these triple constraints: your scope, your time, your money. And it's a very, very critical piece of software. Every organization in the world is, if they're doing projects, they're using project management software. And so we just wanted you to have that opportunity. You're going to be looking at it more from a user, and you're going to be putting in these tasks. But then I want you to back up and say, okay, if I were managing, how, what could I use this to, how help me? Because this is not just about putting it in, but let me even just tell you something else. The act of sitting down and saying, I've got 10 tasks. I can remember when I did my dissertation, I was hired at the university here in August, and I was told that my dissertation had to be finished in April or I would be terminated. I would not get to keep my job. August to April, when you've already defended your defense, that means I've already been before my committee, shown them the study I want to do. Everybody's on par with it. Everybody says it's a good study. Everybody's agreed to the statistics I'm going to do. I mean, it's all been signed off on. The recipe is in the bag. All I got to do is bake the cake. And so I'm sitting here saying, okay, I've got from August to April just to, to collect my data and run these tests and write it up. And so my plan was to be writing by Christmas. And I thought that would be entirely doable. Uh, my dissertation chair made me do a Gantt chart. He made me use some software like this. And I said, Rom, I don't have time for that. I know what I've got to do, and I'm going to get it done. I'm not going to screw this up. This is my whole life. I've been at this for 10 years. I have a job. I mean, he said, I said, do this. And so even though in my mind I had said, well, I'm going to start tomorrow and do this and do this and do this, and I've got to develop my survey, I've got to test my survey, I've got to enter all my data for all of I've got to determine who's going to get the surveys, I've got to mail them out, I've got to wait for them to come in, and then I have to allow time for maybe a second mailing if I don't get enough people to come in. And so the list just kept going on and on and on. And I began to put this down in this software, and I began to see, OMG. So I'm just going to tell you something. Had I not used the software, I would have been in deep doo-doo. I may not be talking to you here today. So I hope you enjoy your lab day, and I hope you enjoy working with the software. And I hope that this video today, and I'm sorry, I'm using a new software and I'm kind of learning as I go, a new software for capturing, and so I keep looking up and reading all of my commands that it's giving me, so please excuse me for being a little lumpy today, and I hope you have a good day, and I hope you all are being safe in all this beautiful white, very cold weather. Thank you.